Today we are going to discuss how you can determine the type of chemical bond that is formed between two elements on the periodic table. Now, the two ways that we can do this is by the location of the elements on the actual table or by using the difference in electronegativity. So, let's get started. All right, first up, what we have here is a periodic table. And I went ahead and grabbed one that was already separated into the three basic groups. But the two groups that we're going to focus on would be our metals and our nonmetals. And hopefully you remember that ionic bonds occur between metals and nonmetals, whereas covalent bonds occur between a nonmetal and another nonmetal. So you can see if something from the metal group bonds with something from the nonmetal group, we get an ionically bonded compound. If a nonmetal bonds with another nonmetal, we get a covalent compound. All right? Well, let's practice this. All right, so this handout here that you have access to in Schoology is asking you to determine whether or not something is ionic or covalent. And what you're doing is looking at the element listed first and the element listed second. And so in our first example, we have NO2. So you're just looking at the N and the O. We're not focused on the number right now. We're just looking at the N and the O. All right, you look at N and its location on the periodic table, and if you don't remember, let's go back. All right, here is N, nitrogen, it's a nonmetal. O is also a nonmetal. So you have a nonmetal bonded with another nonmetal. That bond is covalent. All right, and our second one is MgCl, or is that NaCl? Hold on one second. Excuse me. Well, I think that's NaCl. Either way, if it's Na or Mg, if we look at it, Na is a metal, Mg is also a metal. All right, and then Cl is a nonmetal. So you got metal bonded with nonmetal that will give you ionic. Okay. If we look at our third example that I have not done for you, but we're going to do this together, let's look at S and O. All right, so the first thing we need to figure out is what type of element is S and then what type of element is O. Going back to my periodic table, I see that S is a nonmetal. All right, O is also a nonmetal. And since I have two nonmetals bonded together, then my bond will be, good job, your bond would be ionic. All right, and so that's what you're going to do for the rest of this table. At this time, please pause the video, complete the table that is found in Schoology, and then we will discuss it and move forward. Welcome back. The second way to determine bond type is by looking at the difference in electronegativity. So what I have up here is a periodic table that has the electronegativity values for most of the elements on the periodic table. All right. If you remember, electronegativity is the ability of atoms to attract electrons. All right, and so if you think about that, nonmetals have an almost full outer shell, okay, and the key is to get 8 electrons in that outer shell to achieve what we call an octet. So they have an almost full outer shell, and these elements are the ones that have an increased ability to get more electrons to fill them up. All right, and that's why they have higher electronegativity values. Metals tend to have few electrons in their outer shell, so these elements are the ones that are giving the electrons away. All right, especially in an ionic bond. These are the ones that are giving them away. And so you deal with situations where they have low electronegativity values. All right. So let's look. Oh, I'm sorry. Nope, I needed to go here. So when I say difference in electronegativity, difference means that we are subtracting numbers. All right. So to find the difference in electronegativity for a bond, what you're going to do is subtract the two electronegativity values of the elements found on the periodic table. Now, here's the key. You will not have a negative answer for difference in electronegativity. How is that possible? You will always take the big number minus the small number. For example, excuse me, if I had, let's see, I wanted to find the difference in electronegativity for calcium oxide. Okay, so CaO. I wanted to find the difference in electronegativity for calcium oxide. I know calcium is listed first, but the value is 1. Oxygen, which makes oxide, the ion value is 3.5. So when I take those numbers, I'm going to take 3.5 minus 1, and I get a difference of 2.5. All right. Now, how does that answer 2.5, how does that go into the whole scheme of what's the bond type? Well, depending on your answer, you have three potential bond types. It could be a non-polar covalent bond, it could be a polar covalent bond, or it can be an ionic bond. First off, covalent, whether it's polar or non-polar, you still have a sharing of electrons. The difference is in non-polar, the sharing of electrons is equal, whereas in polar, it is non-equal. Sorry about my writing here. All right. Now, what does that mean? If you had it in the middle, non-polar is like a very even game of tug of war. Both sides are evenly matched. There's no shifting. Polar, you have a stronger side. So the stronger side pulls the weaker side closest to the goal. All right. So that's polar. Ionic is a complete transfer of electrons. Electrons will leave one element and go to the next in an ionic bond. So ionic is like the stronger side grabs the rope and just slings the other side over to where they are. Excuse me. All right, so that's what we will do. So that 2.5 that we got for calcium oxide, where does it fall? Is it non-polar, polar, or ionic? If you said ionic, you are correct. Well, let's practice with this. You have this handout in your notes, well, in Schoology. And so you have a periodic table that has the electronegativity values for most of the elements on the periodic table itself. And this should be a lot easier for you guys to read than trying to read the one that I have posted on this video. So let's look at what you are being asked to do. All right, so for number 1, you have 2 pairs of bonds. All right. What you're going to do is you're going to find the difference in electronegativity and then let me know which one is more polar. So let's look at 1A because I did this one for you. We have C bonded to O right here, and we have C bonded to N. So I go into the table, I find their values, 2.5 and 3.5. 2.5, 3.0, subtract them to get the difference in electronegativity, and I find that the CO bond, the difference in electronegativity is higher, so that means that it's more polar. And that's it. That's what we're doing for that one. Number two, what I have to do is look at the bonded pairs and indicate which element is more negatively charged. What does that mean? Which one has the higher electronegativity value? So I did 2B, C and H, 2.5 versus 2.1. 2.5 is higher, so the C, the carbon in this case, is more electronegative. And then the last one, I am finding the difference in electronegativity. This is for number three. Finding the difference in electronegativity, and then I'm going to determine the bond type. Is it nonpolar covalent, polar covalent, or ionic? Just to give you a refresher from the previous slide, if it is nonpolar, then it has a value, a difference in electronegativity that's less than 5. All right, so it can be 0.4, 0.3, 0.2, 0.1, even 0. All right, you will not have negative numbers. Remember, it's always big number minus little number. Polar covalent, the value is between 0.5 and 1.7, and it's including those two numbers. So 0.5 to 1.7, including those two numbers. That would be polar covalent. And then we have ionic. The difference in electronegativity has to be greater than 1.7, so 1.8 and higher. So 3C was the example. Copper is 1.8, oxygen is 3.5. Subtract those two, you get 1.7, and the bond is polar covalent. So that should be 1.7, and then polar covalent is underneath that. Sorry about that. All right, but that is determining types of bonds. There are two ways that we can do that. Once again, you can either look at the location of the elements on the periodic table versus finding the difference in electronegativity. Complete this handout, and if you have any questions, we will go over them. Okay? All right, everyone. That's it.